So, welcome to the Moose Day. I'm going to start it off with a little presentation about the Moose roadmap. Basically, we'll set up the context for today's conference. So, the Moose roadmap. Before we go on, I want to just clarify what Moose is. So, what is Moose? Anyway, what is Moose? What do you think Moose is? It's an animal, very good, excellent. Now seriously, so what is Moose?
It's a tool for analysis software.
It's a tool for analysis of software systems. Would you concur to that point? It is a tool for analysis of software systems?
Yes. Why software systems? Data in general.
Data in general, that's another point, right? But we don't want to call it really a tool. We want to make a distinction between tools and something we call a platform. So, from our point of view, Moose is a platform for software data analysis. Now, why a platform? What's the goal of a platform? And saying platform is just it's a descriptive thing, but we don't know exactly what the goal of the platform is. Just saying platform. So we've been thinking about it for a while, and I came up with this thing. What Moose is all about, it is about crafting analysis made easy. We just want to make analysis building really easy and cheap. So what does it mean, analysis? Well, let's see, analysis is all about data, and then you get the data, you get some data, and then you get an analysis, and then at the end you produce something. This is what analysis is, right? It's a transformation. You get something, and you get something as an input, you have analyzed that, and at the end you get something else. This has been, it's traditionally has been seen like that for quite a while. And, these are things, for example, in this case here you have visualizations, a browser, and in visualizations perhaps you have algorithms, and there you have maybe metrics, and you have many of those. You can produce many of these with Moose. But Moose is not really about those little pictures there, which they suit very well, they go very well with papers. But we are all about these dots here. And the question is, how are we doing it? And the way we're doing it is simply by redefining, having a very particular view of how and what analysis are made of. And the way we see it, analysis in general is a transformation. Keep that in mind, because we're going to repeat that over and over again. Analysis is a transformation. You get some set of objects and some data, and you get another set of objects as an output. That's all analysis is. It doesn't matter what kind of thing it is, right? If you get some source code and then you measure it, and then at the end you have a number, you get some piece of data, the source code, you have the analysis, which is the metric, and at the end you have the number, which is the result. But sometimes you have the same source code and you visualize that, and then at the end you have a picture. That's also again data. Or sometimes you have the source code and then you have an analysis, which is a query, and at the end you have some subset of that entities of those entities in source code. And this is what analysis is all about. Now the problem with just this view is not the problem, but the thing is that there is no one little analysis. Because there is no one target model that you want to produce. In fact, there are many. The question is, why do we have analysis? Why do we have analysis? We have analysis always because we want to support some sort of a decision. This is always the driving force behind performing the analysis. It must have a goal, and this is really key, because when you start understanding that it's the decision that is the most important, and not the analysis, right? The analysis is not the end goal, it's the decision that is the end goal. And in that case, the context in which the decision must be made is really important. And this is why simply understanding that there is not just one context, there is not just one point of view through which you can see your data is key. And the thing is, we cannot predict all those contexts in which this data will want to be seen. I don't know what all the exact analysis that people will want to make and all the questions that people will ever ask about software systems in general. I don't know that. But what I do know is I know the kinds of questions that people might ask. I probably can predict the types of tools that people might need, the classes, not the actual instances. And this is why an architecture like this doesn't really scale. A different way of looking at the problem is somewhere else, And the other thing about decision making is that decision making is never linear. Decision making is a process, and I call this process assessment. So assessment is purely is a human process. It's not a tooling issue. You need the tools to deal with the size of the data, but it's not a tooling issue. So if decision making or assessment is not a linear process, then it means that we have to accommodate a different kind of a model. And this is what MOOS is all about. For us, assessment of going to a decision is not something, this is the input, press a button, boom, and then make the decision. This doesn't really work. What we want instead, we want to have the ability of iterating and having a dialogue with our data. And the way we do it is like this. We have data, we have recorders, we build the model. Once we have some reification of that model, some objects representing my data, then I start to have analysis, and key number one in MOOS is that all those analyses will produce other models. What does it mean? Well, it means that every time I will do an analysis, if I do a query, I will get another set of objects. And on those set of objects, I can do more analysis. So this is thing number one, right? With this one, I can accommodate iterations. But sometimes I cannot predict the exact things. What exact important do I need? What exact meta model do I need? And model implementation is the most suitable. And I don't know exactly what visualizations you will actually need. I don't know that. And this is why, but I can predict those classes. And this is why we're putting a lot of emphasis on engines. And for us, this is the core area of MOOS these days. MOOS used to be about the upper level 10 years ago. Now it is about this. Now, to show you what I mean, I'll just give a couple of demos. So I have here a MOOS image, and basically I just opened the default interface in MOOS. I say default because we have many interfaces. And what I've done here, I just imported MOOS in MOOS, right? So here, how many of you know Smalltalk here? Excellent. So given that we are Smalltalkers, right, we like that, those kinds of circular analysis. Now the thing here is, the question that I'm always asked is, how many metrics are there in MOOS? It's like, you give these talks about, and assessment is all about flexibility and contextual and so on and so forth. And at the end is, okay, but how many metrics do can you accommodate? This is the key. And the thing is, I don't know how many metrics there are, but I can find out how many metrics there are. So how do I find out how many metrics there are? Well, what I know about this system is I know that there are annotations somewhere in the system. Now I don't know exactly what annotations are, but let's see. So here I'm clicking on all the annotation types that are in the system. I see there are about 33 of them. And there's a list here, so okay. But let's take a look at it in a different way. And now I'm going to visualize it, just all these annotations with a little visualization displaying So what you see here is that all those gray boxes, the big ones, they are the actual annotations, and the little ones, they are the entities that are being annotated. And if two entities are annotated with the same annotation, then we will have connections. And then by using the spring layout, basically you will see clusters of annotations that are being used together. So what I see here is that, I see there are plenty of these kinds of things like package and MSC class, and look at that, MSC property type. That sounds like interesting. So perhaps this is what you're looking for. And then I can tell you, this is what we're looking for.
Wait, can you repeat that?
Yes.
Can you check the int or rational of this one there? Just the one of down, not that one. Can you show the little? Yes.
So now I'm browsing those, and then I see who's using those, and I see,
That we should throw away.
yeah, this is okay. So he's saying that we should throw those away.
That's cool.
Okay, but go back to our original problem. So let's see basically how many MSC properties are there. Well, basically we should find out our MSC property type. Okay, it's this one, this is the annotation. And I see, okay, it's annotated. There are 238 places in which this one is annotated. So let's double check one of them and see if this is correct. I say, okay, this is abstractness of a class group. I have no idea what that is. Oh, that sounds like interesting. Look at that. MSC property abstractness of type number. That sounds like a metric, right? It's a property called abstractness, and its type is a number. That's a good thing. Let's see, are all of them numbers? No. So I don't know, but let's double check this quickly. So now I would just want to go through all my annotation places, all the instances where these annotations are being used. And I'm saying, okay, I'm interested in the second attribute, and the value of that one should be number. Is this true? Oh, only 166 of them are numbers. Okay? And, oh, by the way, that's the answer to my question. There are 166 metrics implemented right now in Moose. Now the thing is, tomorrow there will be 167. Why not? It's very, Moose is made for us to implement a new metric. If a metric is what you want, then you just implement a new metric and it will just appear. Okay, now one thing, perhaps in this case you would want to see where is this, where are these annotations actually being used? Where are they defined? So one way we could do it, would be to say here, so now I have all the places, all these annotations, and if I look at one of these annotation instances of the usage of this annotation within for a certain entity, then I see I can ask annotated entity to it. That means that I can also go here and I can say, for example, well, flat collect me, given an annotation, all the annotated entities of that. So I can print this result. Sorry, let's just collect. And there are 166 methods. That's great. Let's open the results on the other side. So I'm just pressing Apple O so that I can open it on the second side and say, okay, this is interesting. Now, what I actually want here, I don't want this method, but as I would like to have it, for example, I just would like to see the hierarchies in which these things are being defined. So what I want there is I want to get those at the classical. So now I'm opening those. I said, oh, okay, I see there are multiple in Phonics class groups. So what I want here is I just want to say collect a set. And I'm opening, and then see, there are 26 of them. So I could now try to visualize, I would like to see them in the hierarchy in which they belong. Just to play and then now see exactly these properties within the hierarchy in which they belong. Now, one way I could do it is basically I could just right click here and say, show me this little group within the context of all entities, right? And there I could see, this is I can see now the classic system complexity view, right? This is one of those analyses that are built in, and you just click. I didn't do much, right? I just got my object and I clicked on it and I get my visualization. But here somewhere, I see there's a large hierarchy, and this hierarchy, this is where my classes with annotations are. And if I look at the root of it, it's called something moose entity. And if I look at the root of this one, it's called famix entity. And now I know famix is my meta model. It's my language independent meta model, the way I'm representing source code entities. But what are these ones? Oh, okay, these are the groups. Oh, and if I look there and I say, okay, there's a moose model, and there's something called famix class group. And now I will know that we have typed groups. So if you have multiple classes together, they will be typed so that you can have specific properties for a group of entities of the same type, and so on. Now, what I've just done here basically was to quickly build up a little query, right? I built the query on the fly. It was rather visual. I went back and forth because I didn't really know what. I used first the visualization to figure out what should be my first guess. Then I tried to guess. Then I went back and forth. Then I came all the way to this one. Now, what I don't know here is this is my problem right now. You see, this visualization here, this one shows me on the height the number of all methods. But I would like to know only the number of properties, not of all methods in these classes. Only of those annotations. So how many are there? This is how I would distinguish between my classes. So this particular visualization right now, it was useful to see, it's all basically in one hierarchy, but it was not so useful. It didn't really tell me everything. So what I would like to do now is I would like to build a visualization that shows me precisely that. So how do I do it? Well, first of all, now I will just use an engine. I'm just using Rawsol. So how many of you know precisely what Rawsol is? Okay, Rawsol is a visualization engine for anybody else. And with that one, you can do things like that. Right? So I can say, okay, show me the class group, and then show me the edges between them, and showing me the tree length. Very classic, but it's a bit odd. I'm missing I don't have the context. I don't have my all my hierarchies. Right? I don't have the superclasses, so I don't see the inheritance between them. So is there any way I can do about it? Yes, I could go about this and say, I don't know. But you know what? I have here, this is an object now. And I'm expecting these objects, and I see, is there anything I can use here? I say, oh, look, this is of type famix class group. And I go and I browse all these methods that it has, and say, oh, look at that, that's cool. What is that? Oh, I don't know. Let's quickly check it here and see what it is. Oh, look, it seems like it returns me a set of other classes. Okay, you know what? I'm going to use that and see what happens. So I'm just pressing, oh, cool. So basically, what I've just done with this method is a utility method. So I have a group of classes, and because I want to see them in their most common and most narrow context, right? I basically put into the same class group, right? I return another group of classes with all the superclasses in them. It's a very simple operator. But now I have my context, I have my hierarchies. I can visualize these. Say, wow, interesting. And now I would like to put on the height, as I said, just the number of annotations that I have in there. So I can have, a rectangle now. And obviously I can do height and just say, give me the number of methods for these ones, but that's not what I want, right? Because that's precisely what I wanted. I had originally and I didn't want. So now basically I have here a class, and I have to do a bit of magic here. So basically from all these methods, I need to, let's quickly do something. I need to flat so given a method, annotation instances in there. So now I get all those objects that call a certain annotation within this classes, and then here I say, okay, select me given this is an instance, an annotation instance. In there, select.
Why don't you just look at an annotation?
Select. Yeah, but not any. I want just those that have numbers in there. Right? So basically, I'm looking for those that have the attributes. So first of all, the name equals, and you see this one is a bit difficult here. Type and announcement, attributes, second, value equals number, something like this. Okay, so now I will get here basically, I will get here all of these, all the methods, and then I just do size here. Something like this should work. And boom, it does work. So let's multiply that one by 10 just to see a bit more. And there it is. That's my visualization. And that is the power of having something that is super flexible and to drive, it's a companion to my questions. I have the questions, I'm driving, and it should just be there to provide me what I need. Yes?
You could use that to the width and put the height, the method that we put.
I could use that one as the width, he says. And then to put the height to be number of methods. So let's just make that one, it's probably not useful in this case. So now we can see that there's here there are most of them, but not most of them are properties. So there are many implementation details that are not annotated. This is what I'm learning from this particular picture. But again, it's the dialogue that is the most important. And it was always, at any given moment, I didn't just press a button. I always had a question, and the tool was there to help me answer that question. And this is why we are focusing on this one. So what you witnessed there basically was this, right? So you didn't see the importing part. I already gave you the model. And afterwards, we applied a given analysis, which was this annotation constellation. We got a visualization, then we looked into that, so Stefan even wanted to go deeper into that particular model. That was not a dead picture, was it? I could click on it. This is important. We don't want to end up in dead pictures. We always want to continue our dialogue. And afterwards, I did queries, and I got another model, and I did another query, and I got another model. Then I flat collected it, which basically ended up, I collected and transformed the input from one type of input to another type of input. Then I went back into the engine level, so I opened Russell, and then I built my visualization, the first one, and I applied it on that model. I got another model, and then I was not happy with it. I went to the original model, applied another one, and I built another one, and afterwards, at the end, I was happy, and then I can move on. And this is this workflow, right? This is the part of Musa. These are two parts. First is all the time iterative. You always continue the analysis, and second, you have these engines that allow you to customize the whole workflow at any given time. Now, let's take a look at some examples. So, what kind of engines are there? So, first engine, for example, the one that perhaps many of you know is PedidParser. PedidParser is a parser framework. And what this one does is that its job is basically to produce parsers. That's what it does. And the goal there with PedidParser is to have it, to bring the cost of building one parser, make it as cheap as possible. Another engine, so for example, with Petit Parser, right, you can have Petit Smalltalk, that's a Smalltalk parser. Then this one will get Smalltalk code, and then you will put it in there, and then you will build a model. For example, you can build an ASP, or you can even use it to produce Phoenix models out of that. Another example of a similar type is to have something like an XML parser. Okay, this exists everywhere, but we are all about data, so we need to handle that as well. Now, something that becomes more interesting is when you have these engines that try to do multiple things at the same time. So, for example, Fame here is both a meta model with which you can meta engine with which you can describe meta models. But at the same time, it also provides you with a little engine that can serialize and deserialize models in a certain format, in this case MSC, and then you can even move them between, for example, Smalltalk and Java. And it works quite smoothly. And this is what we're using for one of our solutions to parse Java. Another engine is Russell. So you saw Russell now in action. The goal of Russell is to help you build graph visualizations. And what you saw actually was not really Russell, but it was a thin layer on top of it that is called Montreal, and that allows you to do graph visualizations of a certain kind with using this little DSL things. But another kind of an engine that is also dealing with visualization, but different kinds of visualizations, is IC, and this is what we're using to produce charts. Yet another kind of an engine, you didn't see this one, you just saw a browser, or a couple of browsers of that, is Glamour. And Glamour is a more fancier. How many of you know Glamour? So you know that. But what you might not know precisely is that Glamour integrates multiple other lower level presentation engines. So inside this workflow of Glamour, it has this architecture in which you can plug in multiple visualization engines. For example, the editor in which I typed the Russell visualization was a Glamour browser, and it embedded directly dynamically also. I could render something and put it in there. So this is about the engine. This is what we have in there. That is what Moose is, right? So when you look at this, a picture like that, which is a typical picture when you're looking into the Moose panel, what you see here is you see multiple things at the same time. You see, for example, models in here, data is always present, right? You see queries that are very cheap to write. You see visualizations that are embedded in there. You see actually multiple browsers transparently embedded with different workflows in here. And this is all made pretty much seamless. And that's a typical Moose tool. This is something that I'm actually using. Okay, now why is this important? We get so entangled into technology that sometimes we forget why the technology is actually important. And the thing is, that whenever you think of development, right, you think of the whole of a larger bunch, but in the end, right, when you look at what people actually do in practice, they for half of their time they don't write anything. It's not development that they're doing. It's digesting what they already have. Which means that basically for 50% of software engineering is as much about development as it is about digesting what we already have. And yet, when we talk about the prompt time, the real thing, what captures the headline of a magazine is always the upper part. It's never the lower part. And yet it costs us as much. This is, it's not particularly useful. This has to change. It should change, right? It would be economically sensible for it to change. Now, if you put it into context, this is just half of the story. These are just the costs that you can directly evaluate. The costs that you cannot evaluate are those that happen based on decisions, right? So first of all, these decisions, this effort here is useful not just for the person that actually has the rights, or for the developer. But it's also useful for the manager, or for the architect, or for the actual developer. All of them need to make decisions. Some of them don't realize that they're making decisions. Right? It's, whenever I talk about decision making, it's the manager. Everybody associates that with a manager's job. He looks at an Excel file and makes decisions. I'm sorry. But it's not like that. Everybody makes decisions all the time. And we always, even a developer has to, on a regular basis, figure out where to add a certain functionality. So, but what I said about the direct cost, right? This is something you can measure. You just sit next to a developer and then you measure the time. He writes times code and the time is not timing code. This is half of it. But the indirect costs can be seen in the results of the decisions. And the quality of the decision will have an impact on the future development. And this is where the real pain is. So if you don't really pay attention to that, we will not be able to properly control the future development system. And that's where the value of assessment is. And again, assessment is all about decision making, and in order to be able to make proper decisions, you need to have good data. In order to get that data, you need to have analysis. Why? Because systems are just large. And the data that is associated with those systems is even larger. So you need to have tools that help you along this way. And this is the place of Moose. Moose is a platform that makes this kind of, addresses this space. We try to make it explicit. And we make it explicit by turning the problem upside down. Instead of trying to predict and ship 1,000 tools, we will ship slick little tools with which you can build the things you want. Why? And why does this work? So we say Moose is all about crafting analysis made easy. And why does this work? Because software engineers already know how to program. Because they know how to program, we should treat them, for what they are. And this is why Moose is not for clickers. Moose is for programmers. You can tweet them. So, and this is a key distinction between what Moose is and what any other platform you can see out there is. That's a unique characteristic. So this is what Moose is. Now, let's actually talk about the main purpose of this talk, which is talking about the Moose roadmap. So I'm just showing you here the last 2 years, starting from version 4.4. So in the last 2 years, we have 4 versions. There are several things I want to point out here. So the current version, currently released version is 4.8. And the first one, 4.4, not the first one, first. Version 4.4 had R package in it. We introduced IC, we migrated it from VisualWorks. We have a little tool called Metanode. How many of you have ever used Metanode? It's there, it's a little tool inside Moose, and nobody's actually, very few people are actually using it. The code, what is it? So the code in there, actually, the coolest thing about Metanode is that it's really 3 classes. So what is it? Well, what it is this. Suppose now I don't want to, Moose is all about extensibility, so what I could do is I could take all this analysis and put it inside the code and then be able to query it afterwards, right? To say which classes have annotations, of which classes have metrics in it. But if I don't want to do that, if I'm just in a rush and I just want to annotate right now on the fly my model, right? So what I can do now is I'm just, where is it? It's gone. Okay, I cannot show it to you. I could show it to you if it would be here. Okay. This is something. So what you can do with it, if it works, what you can do with it is basically you have it's a bridge between the meta descriptions in Moose, which is Fame, and Magnet. And what you do with it is you can basically handle annotations dynamically. So you can just add annotations to an object and afterwards query them. You can edit those annotations and you can manipulate them, and you can also afterwards query them. So what I could do there is I could just select all those classes and say annotate those with a certain property, and afterwards it would be embedded in my in the object when I could query it. And I would have the user interface for it. Okay, 4.5 was a minor version. Now, why did we do, sometimes we do minor versions. And you will see, the reason why we're doing minor versions is that we want to be very close to the Faro development. So, the reason why we did 4.5 is that in between when we released 4. Right after we released 4.4, in May 2011, they released 1.3, Faro 1.3. So what we've done is that we have migrated from 1.2 to 1.3, and then we released another news. And this was in June 2011. Then in February 2012, we had 4.6. That was again a major version there. So we had quite a lot of improvements in comics. We introduced editors, so those editors that you saw that we could script various tools in them. We had things like the GT inspector, the GT. Anybody knows what this Glamorous Toolkit is about? So Glamorous Toolkit is an instantiation of Moose, but for Faro development. So these are tools that are dedicated to people that are actually developing in Faro. And the GT inspector was the first one. It's very similar to the Moose panel that you have seen. You actually you saw it quickly, briefly. I showed it. So here I have a Finder-like interface, and the same things applies for the same things apply for Smalltalk object. So it doesn't have to be a founding subject. So now I'm inspecting, for example, Smalltalk in this case, and I can see here my Smalltalk object, and okay, I see here's a normal kind of inspector feeding, but I also have the methods around. So I can quickly browse my methods if I want to, and I have my code in there. I can even modify the code on the fly. And then I have globals here. This is Smalltalk, so I have 5,600 elements in there. And that's a system dictionary. So here I could, for example, say each value, so or each key, let's say, each key begins with GLM. And that's a little script, right? And then it says it tells me how many classes here basically start with GLM. GLM is the namespace for Glamour, so now you'll see that Glamour is 265 classes, but this also includes the tests associated with it. Okay, so some other things you can see here, given that we are all about analysis, is let's take some let's take one of these classes, let's say GLM presentation, for example, and let's say, okay, show me all the methods you have, and okay, I see here all these methods on this class. Like an interesting question. Let's pick one that is a bit larger. So this looks like a bit of a larger method. So there I can see the source code, I can see the bytecode if I want to, right? But also I can take a look at the methods. So now I'm looking at the methods in compiled method representing the method that I'm looking at. Sounds cool. One thing I can do in this compiled method, for example, is if I want to, is I can get my parse tree. So getting the parse tree now gives me an instance of the for the ABSA syntax tree. Now, given that I always wanted to find out how Smalltalk is actually represented inside, I thought it's just appropriate that if I see here, if this is a tree, then it should be also And now, given that I want to see how this mapping happens, right, then I should be able to just go and navigate through that tree, and it should highlight me the code below where it belongs. And this is just done on the fly, basically. And there are multiple extensions. The idea of this browser is that every object can represent itself. So yesterday, for example, I showed how you can have spec objects directly embedded into this one, or morphs, or all sorts of other things. Okay, so that's the glamorous inspector. Now, in 4.7, this was another major release. So 4.7, first of all, was released on Firewall 4. And it came with several things. First, we advanced Phonics. Phonics is our meta model, so language independent meta model, to only extensively use Chef. And who knows here what Chef is? Okay, Chef is an API for querying and aggregating information dedicated to Phonics models. So what does that mean? Well, it means like this: that you have a class, and the class has methods, and the method invokes another method. Then you want to see if you have a group of, if you have this class, you want to see all the other classes that are being invoked by this class. So the way we have done it before was to basically have an explosion of methods that were saying this, right? So it will say, oh, you're looking for invocations, so we'll have invocations at the level of the class, and it will be implemented there. So we're looking for the outgoing ones, and then if you're looking for the outgoing ones that are within your package, and then another method for outgoing invocations that are outside of your package, and another one that was outside of your namespace, and so on and so forth. And this, we ended up with thousands of methods. And then Simon Beguet implemented, a while ago, he implemented Chef, which is a much cooler way of aggregating these ones, these queries. So he wants me to show it.
You cannot advertise it like that anymore. I'm an easy career.
Yes. So let's see. So I have here, for example, a mixed class. So this is one of those classes that's annotated with multiple metrics, and this is the super type of all the types. So you can have classes, you can have generic classes, we call them parameterizable class, and so on and so forth. And what we can do here is that so from the method here, if I take a method in there, I can say, okay, look, this method here has outgoing invocations. That means that there are 3 different calls going away from this method. And then it means that I can aggregate that into invoked methods. So now what I would like to do is I would like to get basically all the invoked methods, but aggregated now for the whole class. How do I do that? And there is a couple of very simple operators. So basically here we get something like this. So I say query all outgoing invocations, and this one will aggregate things from the method level and boom, put them at the level of the classes. Okay? And this is a list of them, and then if you want to have it open, then we have it on this side. Okay, so now these are all the invocations I have. So 738 of them that are going out. But now, if I just want to see the classes, the methods that I have on the other side, right, not the object that is in between, not the invocation method, but just the methods, then all I can say is say opposites to that. And now it will give me only the methods, right? Just those objects that are on the other side. But now what I don't want here is the problem is now I have a class, and now I would like to see all the other classes that I'm invoking, right? I don't want to see the whole level of methods. And then you can say here add class. Let's go. Okay, so with this kind of thing, then you can really do very quick ways, and you can combine the context, right? So it's again, we provide you the operators, and you know your context, right? And if you just want to know how many actually there are, then you say, okay, there are all of them like this. So, and you can do that at the level of namespaces or packages and aggregate these kinds of information stuff in different ways. This is Chef. Okay, so we've done Chef. Then the other thing, we have integrated Russell. So before we only had Montreal, but Russell is a much nicer visualization engine. It's built by Alexandre Bergel and Object Profile, and you saw it. You saw a glimpse of that. Yesterday, you also saw a glimpse of the glamorous toolkit, the GT debugger built by André. That's part of the glamorous toolkit, and that's a very cool and flexible debugger. But I will let you watch the presentation for that. Another thing we've added was we added a brand new browser for building Qt parser. So how many of you have seen this new browser? How many of you have used it? So the point here is this. Sorry, I have to show you. What does this mean, a browser for building parsers? Well, the parser looks like this. As you know, so how many of you know Qt parser? Okay, Qt parser is a really cool thing, right? It looks like something like this, for those that don't know it. So this is basically, you can define parsers based on objects, and it's all written in Smalltalk. So they're all Smalltalk objects, and you have very nice operators in there, and it has a little DSL to build this. And as you know, Qt parser maps parsers onto Smalltalk classes. So what you can do is you can actually browse them in normal Smalltalk browser. So I can browse it here. But what I miss here is that, for example, the problem here is this. The problem is that when I have multiplication, let's take a look at factors. You see, factors is using an instance variable multiplication, but this magically maps onto this selector. And this magic is taken care of in the superclass. Right? So, but the point is that the whole point there is that you don't want to initialize the parser every time. You want to cache it and put it once and then have it available as an instance variable, and then you use it like that. But the problem is you're missing this parser. The worst thing is when you're trying to refactor this. Now suppose it's not multiplication, but you want to name it somehow else. Just multiply, for example. And the problem is if I use a normal browser for that, then it will only refactor my selector, just my method, not the instance variable. So in here, I have an instance variable called multiplication. This is one thing. The other thing is I'm not seeing really, it's not really something that is made for building parsers. So this is why Qt parser is a different approach. So the approach here is that we have a dedicated browser that is trying to encapsulate the workflow of building with this parser. So, for example, if I have here addition, so I know that an addition is something like that. I also have something which allows me to quickly inspect the result. So here's the result. And also I have a debugger here saying what productions actually were used to produce this result. What productions were involved during the parsing time. And let's add an error here. So here it says, well, you see in gray, you see all those places that were tried but were not matched, basically. So here they were tried, it tried to do it, but it said it expects parentheses at least or something like that at the beginning. And here I have all those things that were tried but didn't work, for example. But something else, another way of looking at the grammar like this, and this is, by the way, this is a very simple grammar, it's for arithmetic, is you want to take a look at the charts, so you want to see it visually, right? But yet another one, what you don't see here, you sometimes don't see all the dependencies between these grammars. So another way of looking at it is, would be to have a real map, and I can click here and it selects me the right thing, and I have a preview of what the rates. If you have the larger string, then it's nicer from that point of view. You have a self-generating example. Okay, this existed before. But again, if you want to now say, I want to rename this production, and I say multiply, so now basically this should continue to work, and it does, right? Because it performs a refactoring that just conglomerated to the whole thing.
But it's multiply.
There's no multiplication in the expression.
Yeah.
No, oh, really? I don't believe you. So here's, I will try to.
That doesn't matter, I think the parser should have break anyway.
Yeah, exactly. But the point is that you can see here the results of it if you want.
Couldn't you do that just by renaming the method in the browser? Sorry, I didn't follow that part.
No, because now if I now browse this class, you will see that also the instance variable was renamed and did the same refactor. This is something very specific, right? It's a different kind of workflow. It maps on the small points. You can still use that, but it's cumbersome. It's not what you want. And so you see that multiply was actually used. Okay. So this is the Petit Parser browser. We have also all sorts of additions to Llama that I will not show now. Now, let's talk about the future. Let's talk about the future roadmap. So first is for the 8. For the 8, we're going to release that one very soon, probably in May, at the latest. The reason is that in the meantime, Faro has released Faro 2.0. We want to be very close to Faro, and we want to release it on top of 2.0. Currently, for the 8 runs all the tests. Everything is green on for the 8. I'm actually demoing for the 8 and not for the 7 right now. And afterwards, we're going to move to 5.0, and this will be certainly based on Faro 3.0. Now, what do we want to do there? We want to do several things. First of all, we want to rationalize our visualization engines. So right now we have 3. We have Montreal, we have IC, we have Russell, and they are all separate engines. And we all want to bring them under one umbrella. So Russell will provide the basic drawing and capability, and then IC and Montreal will just be thin layers on top and work with the internals of Russell. And afterwards, at the same time, we want to bring Russell to use the new Athens canvas built by Igor. The idea there is that you would have Athens is vector, it provides vector graphics, and we are all about building vector graphics, so it just makes perfect sense to use it and have a beautiful picture. So this will be one major block that we want to achieve under 5.0. Another one is work by, is not here, Jan. We want to see how we can integrate his work on islands, in parsing islands, into Petit Parser. Yet another issue will be about putting together multiple efforts that go into the direction of hierarchical graphs. This is something you will see later today. There will be a demo by Ace. So that's basically it's a generalization of Chef. So if Chef aggregates things for Famix, what Quicksilver would want to do, let you do, and also what Karak tries to do, is to aggregate based on any kind of hierarchical information. And interestingly enough, the same mechanism also happens in the dependency structure matrix implementation. It's hidden somewhere. So all these three we would like to rationalize them and strengthen it into one engine that does nice hierarchical graphs. So that would be very nice to have. Okay, so we talked about the Petit Parser and islands. Another beginning is to use traits when we're defining more meta models. So right now the meta models that we have is really based on a class concept. And what we would like to get is we would like to be able to use traits. And like this we could build meta models even faster than we're doing right now. And that has to work at two levels. So we want to have FAME, so our meta engine, extended to use traits, and we will have to use FAMIs to then afterwards instantiate that. Another major thing we want to go towards is building up this toolkit. So the idea of the Glamorous toolkit is to be built on Glamour and offer a full set of tools that with which you can build Flutter applications. That is the goal. And that means we started with the inspector, we are having a debugger now that is working nicely, and we're moving away. We're moving up towards possibly one or more code browsers, because there's no reason to have only one. And yeah, we'll see along the way. Okay. Last but not least, is that we would like to, or I would like to redo the web page quickly. The reason is that right now the web page is highly, let's say, rather technical, but it doesn't really convey this idea of what crafting analysis is and what's it. And I think it's a really important characteristic that should just transpire, should be very transparent from the web page, and people should understand. We should try to communicate what that means, because it's a completely foreign concept. It's a new concept that we should try to market it a bit better. So Moose is a platform, but at the same time, Moose is a project. And by being a project, it's an open source project. It means it is not defined by whoever. It's not what Moose is that counts. It is what you want Moose to be. So if you have an idea, if you have a project that you would want to have somehow integrated or working together with Moose, then we definitely we welcome your contributions. There is really only one constraint. Our main core mission is to make crafting analysis easy and cheap. That's all we care about. What analysis? What data? How do we do that? That's not so relevant. This is where anybody that is interested in joining can join. Something you shouldn't forget. This works well with the research idea. Moose started in research. It is still highly developed in research. So right now we have 3 research groups that are working. One is here in Bern, one in India in Lille, and one in Chile. They're large efforts actually being put into the software system. But now we also have, so it's not only research, because there are at least 2 companies, so Synaptic and Object Profile in Chile and Synaptic in France. We have consultants that are actually using Moose into production, like me or like Diego. But we should not forget that Moose comes from research. And the interesting thing was, anybody knows how did we get to have this flexibility? Where does this flexibility come from? How did it come to be? Anybody? We wanted to produce papers faster than our competition. That meant we needed to do more experiments, we needed to handle data, different kinds of data, faster than anybody else could. So this is why it became flexible.
So what you are saying is that because we program with our little finger,
Yes.
we produce more papers.
Much more papers.
Don't tell them.
Yes. So this was the cool thing there is that this is a model that works. It's interesting because it's a model that works both for research and for practice. It is relevant in practice. And it's amazing actually, because you don't have that many opportunities out there to actually do both. And there's a model behind it, and we have good second thing, the last thing I want to talk about is Moose and Faro. There is a reason why Moose Day is collocated with the FaroConf. And the reason, actually there are two reasons. First of all, Moose can appeal to a market where Faro has a hard time penetrating. And this market is this market. We can talk with Java developers and they can use Moose. But in order for them to use Moose, they have to learn to program Faro. And this means that Moose is a marketing agent for Faro. And and we were discussing yesterday about how do you market Smalltalk, which is a dead language, right? Well, you market it by through miracles. And the best miracle you can do is to transform the dead into, to bring the dead into being alive again. And we can do that with Moose by simply saying, you know what, you need to solve that problem, here's a tool. What do I need to do? Oh, just learn, this is just little languages here. Just little, instructions. And the language fits into one slide. Isn't that amazing? It's a very simple Excel. And then you say that this is, and then you say, wow. And then they say, this is Smalltalk. And they say, oh my God, it's a miracle. And this is how marketing can work. And this is why Moose can be so important for Faro. But there is a second thing. There is a second dimension of Moose that is really important for Faro, I think. And it's even more important than the first one. And this one is like that. You see, I'm still bothered by the fact that this is empty. This is terrible. This is terrible here. And you think, just because we're programming in Faro, we should not think that we're not affected by this. We are. Every time we're reading the source code, every time we're using some clunky inspector that shows us very rudimentary pieces of information, we're spending time there, with or without being conscious about it. So I think that we should think there's this opportunity with Moose. We turn this problem. We address this space. We build we build science for it. We build a platform for this space. We make it a topic of conversation. Before testing was before test-driven development came to be, nobody really talked. Testing was not a subject of you would go to lunch with somebody. And nobody would talk. Look, you want to know how I'm testing my application? This was not a subject. Nobody was bragging about the way they were testing their applications. Then these things comes, and then now we talk about, do you want to see how cool I can write these mocks? And that's a subject of conversation. And because this conversation started, we have all this tremendous technology now that helps us really be productive at writing tests. But tests are just about functionality. There are many other aspects that are just not about functionality. And they should be equally important subjects of discussions. But for this to happen, right, you need to first have the tools to make it possible. Now we have it, it's here. And the cool thing, it's already in Faro. What we need to do is realize the potential there. Because if you look again at this picture, it means that to some extent, perhaps it's an exaggeration, but to some extent, software engineering is just focused on half of the problem for 50 years. And we didn't really get right the other half of the problem yet. I think this is a fantastic opportunity for Faro. And how would it be if these tools, right, that make it possible for you to have conversations with your system, with real conversations, deep conversations, how would it be if they would be deeply embedded into your environment? Then the only thing you would need to do is you need to coin a term for that. And I call that one assessment-enabled development. And what Faro could be, Faro and Moose together, it could be the Faro is the assessment-enabled environment. And that can be a new paradigm of development. And I think this is really